Welcome to The Explainer. Okay, today we are looking at something that is absolutely going to change how you look up at the night sky. For over a century now, we've had this very specific, kind of terrifying understanding of what happens when a massive star dies. But what if we've been completely wrong the whole time? Theoretical physicists at Goethe University Frankfurt just published a mind-bending mathematical model that totally upends our assumptions about stellar death. They're proposing a framework so radical, it doesn't just rewrite the end of a star's life, it literally rethinks the beginning of our entire universe.
So let's just dive right into this massive question out of the gate. What if black holes simply don't exist? I know, it sounds crazy, right? Because black holes are, for sure, one of the most accepted and famous phenomena in all of physics. We've been told our whole lives that when a massive star dies somewhere out in the cosmos, it collapses into this endless, inescapable pit of darkness. But what if every single time a star died, it didn't actually collapse into a void of nothingness?
What if, instead, it exploded into something else entirely? The researchers from Frankfurt are suggesting that instead of gravity crushing a dying star into infinite darkness, something absolutely extraordinary happens deep inside its core. I want you to imagine a dying massive star not as some cosmic graveyard, but actually as an incubator. You know, a place where a tiny, glowing, brand new universe begins to expand.
Section 1. The Black Hole Problem. Let's take a look at why the old model isn't quite holding up. To truly appreciate the sheer scale of this discovery, we first need to understand the traditional and, well, admittedly flawed, model of how stars actually die. See, scientists have been quietly arguing about a hidden problem with black holes for decades now. Inside every massive star, there's this incredible tug-of-war happening. For millions of years, these giants burn super bright. Nuclear fusion inside their core produces a massive outward pressure, and that pressure perfectly pushes against the immense inward crush of the star's own gravity. But eventually, the star runs out of fuel. Step 1, fusion stops. The exact moment that happens, Step 2 kicks in. Gravity wins, instantly and completely. And that leads us straight to Step 3, a catastrophic collapse where the star just caves in under its own incomprehensible weight. And under the old model, the assumption was always that it just keeps collapsing forever.
And that endless collapse leads us straight to this concept right here, the singularity. Now, this is absolutely crucial because this is exactly where Einstein's general relativity runs into a massive roadblock. The traditional theory says all the mass of that giant star, which can sometimes equal billions of our suns, gets compressed into a single infinitely small point. We're talking infinite mass packed into zero space. The problem with that? The math literally just stops working. The laws of physics, the very rules that govern everything we know about reality, completely break down at a singularity. And for a lot of physicists, a model where the math just throws its hands up and quits, it simply isn't good enough.
Section 2. The gravastar discovery.
Enter theoretical physicists Daniel Jampolsky and Professor Luciana Razzola from Goethe University Frankfurt. They spent years wrestling with this exact problem. They really wanted to know if Einstein's equations could describe something mathematically sound that doesn't require an impossible physics-breaking singularity when a star collapses. And in June 2026, they published a model offering an astonishing answer. At the precise moment a collapsing star is about to be totally crushed by its own gravity, dark energy intervenes. Yeah, dark energy. The exact same mysterious cosmic force that is currently pushing our entire universe apart. Their equations show that as the star collapses, dark energy acts from within, pushing outward against that incredible crushing force of gravity. Take a look at this comparison, because it really is the core of this entire paradigm shift. On the left, we've got the old model, the black hole. That's infinite mass crushed into zero space, causing a total mathematical breakdown. But on the right, we have Jampolsky and Razzola's new model, the gravastar. Here, the inward crush of gravity and the outward push of dark energy reach a perfect, completely stable balance. The collapse is actually halted. The physics don't break down at all. It just makes perfect mathematical sense. So what exactly do we call this stable, balanced object? Well, it's a gravastar. That's short for gravitational vacuum star. From the outside, it's incredibly dense. It has almost the exact same mass and immense gravitational pull as a black hole. But the inside? The inside is where the magic really happens. Because it's being held up by the outward push of dark energy, it actually contains an expanding, miniature universe inside of it. Think about that for a second. An entire cosmos, literally growing within the shell of a dead star. Section 3. A universe within. Let's scale this up.
Let's just pause for a second and let the sheer scale of this idea sink in. We're shifting from the mechanics of a single star to some pretty dizzying existential implications. Look at this number. That is 100 billion trillion. That's the estimated number of stars just in our observable universe. Many of those stars are massive enough to eventually collapse. If Jampolsky and Radzolo are right, every single time one of those massive giants dies, it might be birthing a completely new universe inside itself. The sheer number of alternate universes that might exist right now, just hidden inside the corpses of ancient stars, it's entirely beyond human comprehension.
I mean, really think about what's happening inside the gravastar. You've got a tiny, incredibly dense point of immense energy. It's driven by dark energy, and it's experiencing a rapid, outward expansion. Now, doesn't that sound exactly like something you've heard of before? It perfectly mirrors the exact mechanics of the Big Bang. You know, the very event that created our own vast cosmos of 400 billion galaxies.
Which leads us to the ultimate, truly mind-bending question here. Are we living inside a dying star right now? Seriously. If the conditions inside a newly formed gravastar are totally identical to the Big Bang, then it stands to reason that our universe, literally every galaxy, every planet, every living thing you have ever known, might have simply been born inside the core of a collapsing star in some larger, older universe. We could literally be looking at the inside shell of a gravastar when we look up at the very edge of our observable universe.
Section 4. Hunting for proof. How do we actually know this is real?
As incredible as all this sounds, science obviously requires observation. Right now, this is a brilliant, highly elegant mathematical framework. But how do physicists intend to actually prove the existence of gravastars? Well, finding one is immensely difficult, mostly because from the outside, they perfectly mimic black holes. They've got the exact same exterior mass, the same intense gravity, the same sheer darkness. But they aren't completely identical. Because a gravastar has a structured interior, that expanding dark energy, rather than just a singularity, it's going to react differently when it collides with another massive object. The absolute crucial point here is their gravitational wave signature. When two gravastars collide, they'll essentially ring or vibrate with a tiny, totally distinct difference compared to two colliding black holes.
And honestly, here is the most exciting part. The signals might already be here. We possess incredible technology today, like the LIGO and Virgo gravitational wave detectors, and they've already captured the ripples of countless cosmic collisions. If even just one of those past collisions involved a gravastar, the uniquely distinct data for it is just sitting on our hard drives right now. The literal evidence of multiverses might already be recorded, just waiting for a physicist who finally knows what to look for to analyze the waveforms.
Section 5. A cosmic doorway. We've covered some incredibly dense science in this explainer. From the breakdown of general relativity all the way to the outward push of dark energy. But this mathematical model carries some profound philosophical weight, too. We have always looked at the death of a massive star as the ultimate end, just a violent collapse into an endless dark void. But what if it was never an ending at all? What if every dying star is a door? A doorway where the crushing end of one cosmic story is simply the spark of creation for a completely new, beautiful, and expanding reality. It completely reframes how we view the life cycle of the cosmos. Death on a cosmic scale might